Welcome to lesson 1.3 on exponent laws and working with variable exponents. We're going to get two more exponent laws today, and we will work with using a variable, so that means a letter in the exponent, and solving for it up there. But we're going to start with simplifying powers that have the same exponent, and that's the super important part. Same exponent. Same. 1a says, let's expand these using repeated multiplication. So if I were to do that, 6 to the 3 would be 6 times 6 times 6. And then 2 to the 3 would be 2 times 2 times 2. So 6 to the 3 times 2 to the 3 would be 6 times 6 times 6 times 2 times 2 times 2. And then it asks, is there a compact way of writing 6 to the 3 times 2 to the 3? And you can stop and think. And you might think, well, exponents are just something that's repeated. And really, I've got a 6 times 2 that gets repeated 3 times. So the compact way of writing 6 to the 3 times 2 to the 3, I could write it as 6 times 2 times 6 times 2 times 6 times 2, or I could write it as 6 times 2 to the 3. And that leads us to exponent law number 5. I've got to pop out and then back in because it stopped moving my screen. So when powers have the same exponent and we're multiplying, so if we have like a number a and it's to the exponent number, and then it's times b to that exponent number, that's the same as a times b all raised to that same exponent number. And you can go ahead and guess what it's going to be when we have division. If we have a to one exponent, and then when these exponents, it's got to be the same exponent, right? You can probably guess already what that one's going to be for division, but we'll just check and make sure. So if I use repeated multiplication, I'd have 6 times 6 times 6 up top, and I'd have 2 times 2 times 2 down below. You might notice that we could write it as 6 over 2 times 6 over 2 times 6 over 2. So a more compact way to write this could be 6 over 2 to the 3. So when the exponents match, we can do the dividing and just raise it all to the same, that same exponent. So simplify, writing your final answer as a power. Question 1, 16 to the 17 minus 2 to the 17. I'm going to pick a happier color. So the exponents match, which is lovely. So I can do 16 times minus 2 all to the 17. So that would be minus 32, still inside brackets, to the 17. A different happy color. These guys, the exponents match, so we can multiply the bases. So it's 8 times minus 3 to the 4. So it's minus 24, still inside brackets, to the 4. The exponents, whoops, this stays blue. I want this as yellow. So I've got 20 for the exponents, and they match, but with dividing. So that's going to be the same as 9 divided by 3 to that matching exponent of 20, which gives me 3 to the 20. I'm not going to bother with the colors anymore. The exponents match, so it's going to be 21 divided by negative 3 all to the 8. So that gives us negative 7, still inside brackets, all to the 8. I'm going to do one step for 2 and 4, where we can go one step further. We learned that when we have a negative base and we have an even exponent, that means our final answer will be positive. So if I were to go one step further, and this is what's going to be required on your assessment, we're not going to leave any negative bases. So I'm going to just draw a dividing line here. Do not leave a negative base in your final answer. So here we have a negative base in our final answer, but our exponent is even, and that means we're going to have a positive final answer. So our final answer here would just be 7 to the 8. Oh, I missed number 1. 1 also has a negative base, and here we have an odd exponent. So that means our final answer is going to be negative 32 to the 17. And I'm just, oops, wrong way. I'm going to just separate those. So we can't leave a negative base in our final answer. Super important. Exponent law 7. Use the following examples to find a general rule for exponents of 0. You might know it already, but we're still going to walk through it. So 5 to the 3 divided by 5 to the 3. 2 ways of looking at this. The first way is to do it old school. So if we do it old school, that's the same as 5 times 5 times 5 divided by 5 times 5 times 5. And if I were to cancel, it very nicely, everything cancels all to ones, and we're left with just that equals 1. With our exponent laws, if we look at this, we get 5 dividing, the bases match, so we subtract the exponents. So that's 5 to the 3 minus 3, and that's 5 to the 0. And you'd be like, I'm not sure what 5 to the 0 is, but hey, when we did it old school, we found it equals 1. So 5 to the 0 must equal 1. This equaled 1. We got 5 to the 0 here, so 5 to the 0 must also equal 1. And the same thing would bear true if we were looking at it with A's, so 7. That's a lot of A's to write. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. They all cancel out. A into A leaves us with ones. They're all going to cancel into each other, and we're going to be left with ones, and this whole thing is going to equal 1. Whereas if we followed exponent rules, we'd have A dividing, bases match, so subtract the exponents, A to the 0. But since this is the same thing, A to the 0 must equal 1. In exponent law 7, anything, any number at all to the exponent 0 equals 1. We're just going to have to be careful because it's only what's inside the brackets. So if you had negative of a number to the 0, only this part equals 1. So our negative would stay out front, and it would equal negative 1. So just to keep that in mind. So we're going to practice evaluating all of these. So 3 to the 0 equals 1. Plus 1 to the 0 is 1. 5 to the 0 is 1. Minus 6 inside brackets is also 1. So that one is just 4. For question B, we're going to have to use what we just learned. Hey, look at this. The exponents match on these ones. So I'm going to have 3 times 4 to the 5 divided by 12 to the 4. That gives me 3 times 4 is 12 to the 5 divided by 12 to the 4. Oh, isn't that convenient? Now those bases match. We're dividing, so we're going to subtract the exponents. So we get 12 to the 1, which just equals 12. Question C. We've got this part here, this term, that we're going to have to do the timesing and dividing before we do anything else. So let's see what we get. 3 to the 0 is 3, plus 3 to the 4 is 81, plus 3 squared times 3 to the 3 is going to be 3 to the 2 plus 3, because the bases match, so we added these exponents. And this is going to be divided by anything to the 0 is just 1, so it's going to be divided by 1. So we're going to get 3 plus 81 plus 3 to the 5 divided by 1. Well, divided by 1 doesn't change it. 10 divided by 1 is 10. A billion divided by 1 is a billion. So 3 to the 5 divided by 1 is just 3 to the 5. And 3 to the 5 isn't in my brain right now. So if I use my calculator, 3 to the 5, that's 243. So it's 3 plus 81 plus 243. And when we add those all together, I got 327. Question D. We've got this term, and then we've got the bracket. And inside the bracket, we're going to have to deal with that part first that I just highlighted green. So outside of the bracket, these guys, the exponents match. So I'm going to multiply the bases to the power of 4 minus, big bracket. Minus 2 to the 0 is just 1. These guys here, the bases are different, but hey, look, the exponents match. So that's going to be plus 15 divided by 5 all to the 3. So I'm now going to do new colors. I'm going to do that multiplication and I'm going to do that division. And when I do it, I get 8 to the 4 minus 1 plus 3 to the 3. So 8, actually I'm going to figure out what 8 to the 4 is on my calculator. It's a big number. It's 4096. 4096 minus bracket 1 plus 3 to the 3 is 27. So 4096 minus 28. And I used my calculator and I got 4068. That's it for exponent 0. The last part of this lesson is variable exponents. So it says, sometimes we are asked to solve for unknown exponents. We can use exponent laws to help us solve for them. First, we need to learn one very important fact about exponents. So here is our fact. B to the m equals, if b to the m equals b to the n, then it must follow that m equals n. And basically what it's saying is, here we have the bases are exactly the same. Bases are the same. If the bases are the same and we've got an equal sign in the middle, and we do, then it means that if the bases are the same with an equal sign in the middle, then the exponents must match. Then the exponents are equal. So if two powers are equal and their bases are the same, then it follows that their exponents must also be the same. That's just words saying what we wrote over there in red and green. So for example, if we know that 2 to the x plus 4 equals 2 to the 19, it then follows that the exponent, x plus 4, has to equal 19. And then however you solve this algebraically, I would do it by moving the plus 4 to the other side. We would get x equals 19 minus 4, or x equals 15, which is what the note got. So we're going to be doing this. We're going to be trying to get the bases to match on each side of the equal sign. And once we do that, we can solve for our variable or our x or our n. So the practice question says solve for the value of x. And this part's going to be so important for getting marks on your assessment. You must set up an equation based on exponent laws and solve the equation for full marks. That means even if you look at question A and you're like, okay, well, I know that I have to add the exponent, so I know that x equals 5. If you just write down x equals 5, that's not going to be enough here. For the communication part, you're going to have to show that you can solve, use exponent rules explicitly and then solve for it. So let's use the exponent rules. The bases match, so we're going to add the exponents. So 7 to the x plus 3 equals 7 to the 8. And now we have exactly the situation shown above. We've got matching bases. That means our exponents are going to match as well. So I'm going to write it like this. Therefore, x plus 3 must equal 8, and then x equals 8 minus 3, or you don't need that step. You do need this step, and you do need that final answer, and you do need to show this step. So with those 3 steps, even though you could maybe see right away the answer is 5, that's what's going to get you your marks. Okay, in question B, we've got 2 to the x raised to the 3, so that's a power of powers situation. So 2x times 3. If we think about x times 3, normally we're going to write that as 3x. So that's going to be 2 to the 3x equals 2 to the 21. Our bases match. We've done it. That means our exponents are equal. So therefore, 3 to the x has to equal 21. To get x by itself, I would undo the multiplying by dividing. So divide both sides by 3, and I would get x equals 7. Okay. A little bit trickier, but not really, because you're good at these exponent rules now. Power of power for there. So I'm going to get on this left side 5 to the 6 times 2 times 5 to the x divided by 5 to the 15 equals 5. So that gives 5 to the 12 times 5 to the x divided by 5 to the 15 equals 5. If I use exponent laws, right here, all the bases match. So that's going to be an addition. Dividing is going to be a subtraction. We're going to get 5 to the 12 plus x minus 15 equals 5. So we're in the situation where we've got an equal sign. The bases match on both sides. So that means our exponents are going to be equal. But what's the exponent here? There's nothing there. Well, there is. There's only one 5, so it's going to be 5 to the 1, or sometimes I call that a ghosty 1. So when you do that, that's going to give us our algebra. So therefore, 12 plus x minus 15 equals that ghosty 1. And now we want to solve for x. So I'm going to collect my like terms here. So minus 15 and 12. When I add those together, I get minus 3 plus x equals 1. Now I'm going to take that minus 3 to the other side, or add 3 to both sides, however you want to think about it. I'm going to get 1 plus 3, and my final answer would be x equals 4. Okay. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9 of these to go through. I'm going to work through all of them. You don't have to watch through all of them, but you do have to know we are going to go through a bunch of these in class. Here, bases match. So I can write this as 3 to the n plus 7 equals 3 to the 18. The bases match. We got an equal sign in the middle. So that means therefore n plus 7 equals 18. Subtract 7 from both sides. 18 minus 7. So n equals 11. Here, they're all 5s, which is great. So bases all match. We're going to add when it's a times. We're going to subtract when it's a divide. So 5 to the n plus 3 minus 6 equals 5 to the 2. We get 5 to the n minus 3 equals 5 to the 2. We've got an equal sign. The bases match. That means the exponents must be equal. So therefore, n minus 3 equals 2. N equals 2 plus 3. So n equals 5. And actually, I think these are going to be really good ones for us to do together in class. So I'm going to stop there. Thanks for watching.